we continue solving questions. So find the period and phase shift of the function f of x is equal to negative 1 minus 5 cos 2x plus pi. Now the period of this function, period is given by 2 pi divided by b. Now where this b is the number that is in front of the x, so in this case that is a 2, and so the period of this function is pi. Let me just write it here, pi. Now what will be the shift? So I've got shift in the x. Shift in the x, what we are going to do is we are going to just get what is inside there and equate it to 0. So that is 2x plus pi is equal to 0. So that will be 2x is equal to negative pi, and then x is going to be negative pi over 2. So this is the shift in the x. X is equal to negative pi over 2. And then the phase shift in the y, just look at a constant, this number here, so it's negative 1. Alright, so now the second question is saying hence sketch the curve. Now for us to sketch the curve, let me just add one more thing. The amplitude is given by the absolute value of that number in front of the cos, that is 5. So the absolute value of negative 5, which is equal to 5. Okay, so that is the amplitude. Well, you can go on now and sketch the graph. Okay, alright, so let's consider the graph. The graph has moved up to negative 1. That's where it's starting from. So on negative 1 we're going to put a line. Okay, this is negative 1, and then the amplitude of this function is 5. So that means you are moving 5 units from negative 1 going up, and then we are moving 5 units from negative 1 going down. So actually the way I should have made this graph, I should make the down part much bigger because it will be more on the down. Okay, alright, something like that. This is y, and then this is x. So we are saying it is starting at, the symmetric point is at negative 1, or the shift in the y is at negative 1. So moving negative 1 units from negative 5 units down from negative 1, we are going to reach at negative 6. So let's say negative 6 is here. And then from negative 1 move 6 units up, 5 units up, we are going to reach at negative. So all we do is negative 1 plus 5, we are going to reach at positive 4. Okay, so there is a 4, there is a 6, there's a negative 1. So all we do for us to find the greatest value and the least value is just to the shift, add and subtract the amplitude. So negative 1 plus the amplitude is 5, we get 4. Negative 1 minus 5, we get negative 6, there where it's going to reach. Now we know that this function has got a shift in the x and is starting at negative pi over 2. Okay, so that is, yes, a negative pi over 2 is here. Now if the period is pi, as we can see, where are we going to reach? So if we are starting at negative pi over 2 and the period is pi, then we are going to reach, to complete the revolution, it will be on pi over 2. So it is more like if the journey takes 2 hours and you start at 15:20, just add the time that we are going to start to the duration of the journey to find when we are going to reach. So same, we are starting negative pi over 2 and then the journey takes pi, so we're going to reach at pi over 2. Alright, so now having known that, because this is a cosine graph either starts on the minimum or the maximum. So just look at the sign of the amplitude. In this case it's negative, so it's going to start on the minimum. So we know that it's starting at negative pi over 2, but it will start on the minimum here. Okay, and then after pi over 2 is going to finish a revolution, it will end there. So if we add this and then divide by 2, negative pi over 2 plus pi over 2, that will be 0. So for it to reach the maximum, it will be at this point. Okay, now where is it going to cut? Where is it going to cut this symmetric point or the symmetric lines I've drawn here? So what you do is add this and the middle, that is 0, and divide by 2, so that will be at negative pi over 4, and at positive pi over 4 it is going to cut this line on those points like that. So you can go on and draw. So the graph is going to move. I need to make it as smooth as possible so that to be much better. Alright, so it's supposed to come and pass at that point and then move like that. Where we are not supposed to draw a V, don't draw a V. Alright, now they've told us to do it between negative pi and positive pi, so we are again moving some, going up to pi, and then here also reaching up to negative pi. Now if you consider the period here is pi, now for us to move from here to here, how many waves are we going to make? For us to make only one wave, we need to take pi, but from pi over 2 to pi, the duration is pi over 2, so that means we're only going to make half a wave. Okay, so from here we're supposed to turn, and what do we mean by half a wave? So for a wave, you can see it is a go and a come, so that means it will just be a go like that. It's just half a wave. Alright, so to proceed with this, and then on this point, the half, that's where we're going to come and pass this point. And even this side, the half here, is where we're going to come and pass this point, and then it's going to come and reach on the maximum. It will also go and reach on the maximum there. So the graph is going to proceed on the negatives, like that, and then also on the positives is going to proceed like that. Well, so this is the graph that we are going to show on the given range of values. So please, let's not draw V's. It is a sketch of a diagram. Alright, let's consider the second one, or the third. Find the general solution. So we've been given 2 sine squared theta minus 3 cos theta is equal to 0. Well, we have got 2 different trig functions, so we know that where there is sin squared we can replace with cos, so this will give us 2. Where there is sin squared we can replace with 1 minus cos squared theta, then minus the 3 cos theta, and that is going to be equal to a 0. And so 2 by 1, that is a 2 by cos that is going to give us a 2 cos, that is squared theta, and then minus sin minus the 3 cos, theta is equal to 0. Can take everything over the other side, so take this, it becomes positive 2 cos squared theta. Take also this, becomes positive 3 cos theta. Take 2 that side, becomes negative 2, and that is going to be equal to 0. Okay, at this point, if we multiply this and this, the product is negative 4, and then the sum is this number 3, because this is in form of a quadratic equation. So what two numbers can we multiply to get negative 4? If we add them, we get a 3. So that is 4 and negative 1. So this becomes 2 cos squared theta plus 4 cos theta minus cos theta minus 2 is equal to 0. You can factorize out the first 2 and the last 2. So the first 2 is 2 cos theta, open brackets, cos theta plus 2. And then the last 2 can remove a negative 1, and then we're going to remain with cos theta plus 2, and that is equal to 0. So this is 2 cos theta minus 1, and then cos theta plus 2 is equal to 0. So what are we going to have here? 2 cos theta minus 1 is going to be equal to 0, or cos theta plus 2 is going to be equal to 0. Well, this is going to give us 2 cos theta being equal to 1 if we take 1 the other side, or cos theta is equal to negative 2. So for this one, we can't solve it. A cosine graph only alternates between 1 and negative 1, so it can't go beyond negative 1, so this one can't be solved. So we concentrate on this one. So dividing by 2, that will give us cos theta is equal to 1 over 2. So to remain with theta, we're going to take the cosine inverse of 1 over 2. The cosine inverse of 1 over 2 is 60 degrees, which we can also give in radians, that is pi over 3. Well, we know that cos is also positive in the fourth quadrant. For us to find the fourth quadrant angle, it is theta is equal to 360 minus the angle in the first quadrant, that is the 60. And so 360 minus 60, that is a 300. We could have also worked in radians by saying 30 is equal to 2 pi minus pi over 3, and this would have given us 5 pi over 3. Okay. So now we want to write the general solution and not to find the solutions. So if we check, if we can just represent this on a diagram, 60 degrees or pi over 3 is there. And then the 300 degrees is in this quadrant, something like that. Now the question is, how many revolutions should we take for us to move from here going back? What would be the angle if we want to go back to this point, apart from just turning the first turn? So the thing is, if we move like that, we are going to reach this angle. We can also make a revolution, we will reach there, another revolution will reach there, another revolution will reach there, another revolution will reach there. It doesn't matter the number of revolutions we'll be reaching there. That's a general solution. Same with the other one. If we go like this, we'll reach there, again another one will reach there, another revolution will reach there, another revolution. It doesn't matter. All we are doing is we are making a complete revolution, because we are starting from the beginning to that point, and then again to that point, another revolution. In other words, to the very angle which we add, we are just adding 360. The answer we find, we add another 360, another 360, another 360. So the general solution is going to be 260. For us to come back at 60, we need to add another 360, and then to 300. For us to go back to 300, we need to add a 360, because if we are at this point, for us to come back to this point, we need to move a complete revolution. But it will happen for a continuous number of times, and so we just put n, 360 n, where n is representing a positive integer. So if n is 1, that means we've taken 1 revolution. If n is 2 revolutions and such a thing. So that will be the value for that one. Then consider this one. If a is equal to 1 plus cos x divided by sin x, so they've given us that a is 1 plus cos x divided by sin x. Now we want to prove that a plus 1 over a is equal to 2 cosec x. A plus 1 over a is equal to 2 cosec x. How do we get to prove? Well, let's get the a. So we are saying a plus 1 over a. What is it going to give us? If we can match this as a single fraction, this will give us a squared plus 1 divided by a. Okay, so where there is a, we are going to substitute this, and so that is 1 plus cos x divided by sin x squared plus 1, and then divided by 1 plus cos x divided by sin x. What I'm doing is substituting where there is a. So if I can square what is on top, I'll get 1 plus cos x squared. In the denominator, I'll get sin x squared, or sin squared x, and then plus a 1. So what is in the denominator here? Instead of me writing divide by, let me say divide by, and then I write it as 1 plus cos x divided by sin x. We can proceed now from there and say that's the same as on what is on top. If we can square that, we are going to get 1 plus cos squared. We are going to get 1, and then plus 2 cos x, and then plus cos squared x, and then divided by sin, okay, that is a sin squared x, and then plus 1. So it becomes a times. We're going to change this into a multiplication. So what is down becomes on top, and then what is on top goes down. 1 plus cos x. Okay. Now at this point we can proceed. We can make this a single fraction. What is inside there? So to make it a single fraction, all we do is multiply what is on top of this fraction by what is in the bottom of the second fraction, so that will just be the same thing. 1 plus 2 cos x plus cos squared x, and then what is down the first fraction multiply with what is on top there. That is going to be plus sin squared x, then divided by the two denominators, also multiply them. That is sin squared x times 1. It will just be like that, and then we're also multiplying by sin x plus over 1 plus cos x. So cos squared x plus sin squared x is a 1, so put a 1 there, and this 1 plus this 1 will give us a 2, so that will be 2 plus 2 cos x, and then divided by this sin will go with this, so we'll just remain with sin, 1 sin, because it was sin squared, and then times it, so we'll remain with the 1 there, and then you will remain with 1 plus cos x. So what I can do is I can factorize out a 2 on that one, so that will be 2 1 plus cos x, and then divided by, we have got sin x, and then I can multiply with this, the sin x, so that will be 1 plus cos x. So this and this cancels out, so we remain with 2 divided by sin x, which you can also say as 2 multiplied by 1 over sin x. Is the same thing. So this is 2. The reciprocal of sin x, 1 over sin x means cosec x. So we have shown, or hence proven. Okay, let's consider the other question we have. We've been given to sketch the graph of log in base 2 of 2x minus 4 plus 3. Now really sketching this is quite simple. We just need to understand some things. Well, for a logarithm always has a vertical asymptote, and so this value we can see here, 3 shifts, is a shift. It has shifted the vertical asymptote, and so it is now at positive 3. Okay, so the vertical asymptote is at positive 3, like that. Now we need to look at the sign of the logarithm. The logarithm itself is positive, so that means the logarithm will be increasing towards the positive values of y. Now we need to look at the sign of x. X is also positive, so it will be also going towards the positive values of x. Okay, so to be going like that. So that will be the sketch of this function. So if x was negative, that means if it was negative 2x, the graph would have gone towards the negative values of x, like that. And if there was a negative in front of the log, but this one maintained, that means x is positive but the log is negative, so it would have gone in the opposite. It would have been going towards the positive values of x but towards the negative values of y, like that. If both the log was negative, if the log was negative and the x was also negative, it would have been going towards the negative values of y and towards the negative values of x. It would have gone like that. Okay, so those are some things that we need to get to understand. And so our point is to find the value here where the graph cuts the x-axis, and we know that where the graph cuts the x-axis, the value for y is 0. So we are going to say f of x is equal to log in base 2 of 2x minus 4 plus 3. So the f of x is going to be 0. So 0 is equal to log in base 2 of 2x minus 4 plus 3. So I'll take 3 the other side, so that would be negative 3 is equal to log in base 2 of 2x minus 4. So I'll say 2 to the power, this we can express as an exponential. So this is 2 to the power negative 3 should be equal to 2x minus 4. 2 to the power 3 is the same as 1 over 2 to the power positive 3, and that is going to be 2x minus 4. 1 over 2 to the power 3 is the same as 1 over 8, and that is equal to 2x minus 4. I can take the negative 4 this side, so I'm going to have 2x is equal to 1 over 8 plus 4. So 2x is going to be 8 multiplied by 4, set 32. 32 plus 1, that is a 33. So this is 33 over 8. Okay, we want to remain with only x, so divide by 2. So the x is going to be equal to 33 over 16. So this value here is 33 over 16 comma 0. Alright, so that is the sketch. Now another question we've been given here: find all solutions in the range negative 2 pi is less than or equal to x, which is less than 2 pi, for the equation 3 cos 2x plus 1 is equal to 5 over 2. Okay, so what we are going to do is we are going to take this one the other side. So that is going to give us 3 cos 2x is equal to 5 over 2 minus 1. And that will give us the 3 cos 2x 5 over 2 minus 1, that is 3 over 2. At this point I don't want to see this 3 in front, so I'll multiply everything by 1 over 3. So I will remain with cos 2x is equal to 3 cancels out with this 3, then this 3 also cancels with that, so I'll remain with 1 over 2. Well, to remain with 2x, I'm going to take a cosine inverse of 1 over 2. Because we are working in radians, as we can see, the range has been given in radians. So I'll say 2x is equal to cosine inverse of 1 over 2 is a 60, which is pi over 3. Now cos is also positive in the fourth quadrant, so I'll also say 2 pi. How do we find the angle in the fourth quadrant? Is 2 pi minus the angle in the first quadrant we found. And so 2x is equal to pi over 3, comma 2 pi minus pi over 3. That is going to give us 5 pi over 3. Now because this is the double angle, to these two angles that we have found, to them we are going to add the 360, because it's a double angle. So plus 2 pi, and then also the 5 pi over 3 plus 2 pi. Okay, so this is going to give us 2x being equal to pi over 3, comma 5 pi over 3, comma pi over 3 plus 2 pi. That is going to give us 7 pi over 3. 5 pi over 3 plus 2 pi, that is going to give us 11 pi over 3. Okay, now we want to give answers only between negative 2 pi and positive 2 pi. Well, what we need to know is that cosine is an odd function. That means f of negative x is the same as f of x. So before we even do this, we need to divide by 2 for us to find the value of x. So x is going to be equal to everything divided by 2. In other words, we just be multiplying the denominator by 2. So this would pi over 6, then 5 pi over 6, then 7 pi over 6, and then 11 pi over 6. So I've only given the positive values, and all of these are below 2 pi. Okay, because 6 into 11, it will not reach to 2. It's just 1 point something. So I've gotten the positive portion, but what of the negative 2 pi? So as I've said, cosine is a even function. Whether we use a negative value or a negative or a positive value, the answer is the same. So that means to these, they can either be positive or negative. It will still be the same. And so to conclude the value for x, I'm going to say therefore x is equal to, the smallest we are going to have is negative 11 pi over 6, followed by negative 7 pi over 6, and then negative 5 pi over 6, and then negative pi over 6, and then positive pi over 6, positive 5 pi over 6, and then positive 7 pi over 6, and then positive 11 pi over 6. So all these are the angles which are between negative 2 pi and 2 pi for this question. Well, consider the last one here.